Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at the limits of a function. And under this limit of a function, we'll be looking at three methods of limit, which are the direct substitution method, the L'Hopital's rules, and lastly, we'll be looking at the limit to infinity. So please, before you watch this video, please like this video, hit the subscribe button, and lastly, don't forget to turn on the notification bell so you won't miss any updates from Tech and EduSpark Hub. And stick with me till the end, and let's enjoy the best out of the lesson. So what do we understand by limit of a function? By definition, the limit of a function describes a value a function approach as the input approach a particular point. So let me just write that down, and you can put that down as well. So this is a simple definition of the limit of a function. It describes the value a function approaches as the input approach a particular point. So like I said earlier, we'll be looking at three methods of limit. We have several methods. So let me just write the three methods that we'll be looking at in this video. So these are the three methods of limits that we'll be looking at. We'll be looking at the direct substitution method. Also, we'll be looking at the L'Hopital's rule. And lastly, we'll be looking at the limit to infinity. So we have several methods. It is more than this, but these are the one that I think it is the most important one that you need to know. So we have other methods like the H method. We have series expansion methods. So the series expansion method is used for trigonometric functions. So let's just master this theory and you'll be able to solve any question under the limits of a function. So let's look at all these three one by one. So starting with the first method of limit, we have the direct substitution method. So by definition, it says that if f of x is continuous at x equal to a, the limit can be found by substituting x equal to a in f of x. So this is the simple definition of the direct substitution method. So mathematically, the direct substitution method is given as lim f of x and x tends to a to be equal to f of a. So this is what this definition is telling us about. So this definition is telling us about that if we have something like limit of f of x, so we can simply find the limit by substituting x equals to a to this f of x. So that is how we have f of a. So this method is used when you don't have an indeterminate or undefined answer. So just for example, you can only use this method when you don't have something like 1 over 0 or 0 over 0 or infinity over infinity. So this is when you can use the direct substitution method. So you just have to use the method when you don't have something like your denominator to be equal to 0. That is when you can use the direct substitution method. So let's look at examples and see how this direct substitution works. So the first example we have says that find the limit of lim x tends to 3 at 2x plus 5. So how do we solve this question using the direct substitution method? We said using the direct substitution method, you can just simply substitute a for x to get f of a. So how do we use that in our question? So the first thing to do is to write what is in this bracket first. So writing that down, we have 2x plus 5. And once you write this down, you can see we said x tends to 3, which means x is equal to 3. So from what we know here, we know that x is equal to 3. So knowing this, we can just easily use the direct substitution method to solve this question. And to use the direct substitution method, we can say 2 open brackets. What is our x? So we can just substitute for x directly, which is 3. So we have 2 open bracket 3 plus 5. And when we solve this, 2 multiplied by 3 will give us 6. And we have 6 plus 5. And our final answer will be given as 11. So 11 is correct to this kind of question. So you can see how the direct substitution works. So the only thing is just that you find what the x approaches, which is 3 in this case. And once you get that, you substitute it for x in whatever equation you were given. So in this, we are having 2x plus 5. So we substitute x for 3, and that is how we get 11. So this is how you use the direct substitution method. So let's look at another question still on the direct substitution method. So the second question we have, as displayed on the screen, the question says find the limit of x at 5x minus 3 when x tends to 1. So can you try to pause this video and solve this question? And once you are done solving, you can resume back to playing this video, and once I finish solving it, you can check if you are correct or wrong. So pause this video now and give it a go. So in order to solve this question, I said what we are going to do first is to write what is in this bracket, which in our case is 5x minus 3. And from this question, using the direct substitution method, we know that x tends to 1. So that means x is equal to 1. And to solve this, we can just simply substitute x to 1. So in substituting, we have 5 open bracket. So wherever we see x, we'll substitute it for 1 because x is equal to 1. So we have 5 open brackets, 1 minus 3. And once you multiply this, we have 5 minus 3, and our final answer will be equal to 2. So you can see option A is correct to this kind of question. So 2 is correct to this kind of question. And this is a way you use the direct substitution method. Just find what your x tends to, and in this case it is 1. So once you get that, you can just easily substitute directly and you will get your final answer. So let's look at another example still on the substitution method. And moving to the next question, as displayed on the screen, the question says find the limit of x cubed plus 4x at x tends to minus 2. So in this case, you can try to pause this video again and try to solve it, and once you are done, you can resume back to playing the video, and once I solve it, you can check if you are right or wrong. But either way, you are learning. So in order to solve this kind of question, I said the first thing to do is to write what is in this bracket, which is x cubed plus 4x in our case. So now that we have written what is in the bracket, looking at this limit, we know that x is equal to minus 2 because the function is telling us that x tends to minus 2. So we can just easily use the direct substitution method to solve this kind of question. And in doing that, we have so we are going to substitute minus 2 anywhere we see x. So this is x cubed, so we have minus 2 cubed plus 4 open brackets minus 2. So minus 2 cubed will give us what? Minus 8. And 4 multiplied by minus 2 will give us minus 8. So minus times plus will give us minus. So we have minus 8 minus 8. So how do we add this together? So it's just like saying you are owing someone 8 and you are owing another person 8. So when you add what you are owing together, you'll be having minus 16. So we are going to have minus 16 as our final answer. And looking at the option we have, option D is correct to this kind of question. So minus 16 is correct to this kind of question. So let's look at the last example on the substitution method. But this example, it is going to tell us if we are going to use substitution method or not. Remember I said the only way you can use substitution method is when you have a linear equation like this, or you have an equation that does not give you an indeterminate answer or undefined answer, just like 1 over 0, 0 over 0, or infinity over infinity. So let's look at the last case on the substitution method. So moving to the last example on the direct substitution method, let's say we have something like limit x squared minus 4 divided by x minus 2 at x tends to 2. So let's say we have question like this and we are asked to solve this question. So let's see if we can use the direct substitution method to this question. So in using the direct substitution method, we know that x is equal to 2 from this limit. So we have x tends to 2. So I said we are going to write what we have in the bracket, which is x squared minus 4 divided by x minus 2. So applying the direct substitution method, anywhere we see x, we will substitute it for 2. So we have 2 squared minus 4 divided by 2 minus 2. So in this case, we have, so 2 squared will give us 4. So we have 4 minus 4 divided by 2 minus 2 will give us 0. So 4 minus 4 will also give us 0. So we have 0 divided by 0. So in this case, you can see we are going to get an undefined. So we are going to get something like undefined or indeterminate answer. So in this case, we are not going to use the direct substitution method, because if we use the direct substitution method for question of this type, we are going to get what? Undefined or indeterminate answer, and we don't want that in our case. So this is what bring about the L'Hopital's rule. So let's look at the L'Hopital's rule and see what that is all about. So moving to the second method of limit, we have the L'Hopital's rule. So the L'Hopital's rule, this is used when the direct substitution method gives an undefined form like 1 divided by 0, 0 divided by 0, or infinity divided by infinity. So in this kind of question, when you get anything divided by 0, you are not going to use the direct substitution method. You are going to use what? The L'Hopital's rule. So how does the L'Hopital's rule work, and what is it about? So let's take this as our first example. What we solve initially using the direct substitution method to get an undefined answer, let's try it using the L'Hopital's rule and see the difference between the two. So the first thing to do as usual is to write the equation in the bracket, which is x squared minus 4 divided by x minus 2. So this is what we have initially. So in order to use the L'Hopital's rule, the second thing or the first thing to do is to differentiate everything in this equation. So how do we differentiate everything in this equation? So recall that if we have something like ax squared, in order to differentiate this, the power will come to the front and multiply what we have initially, which is ax, and also the power will be subtracted by 1. So we will get 2ax to raised to power 1. So we don't need to write the 1 because it is just 1. So anything raised to power 1 is that thing. So what we are going to do, we are going to differentiate x squared, also differentiate 4, and also we are going to differentiate x and 2. So let's differentiate x squared and do it here before writing it there. So in order to differentiate, we have x squared. So I said the power will come to the front, which is 2 multiplied by x raised to power what? 2 minus 1. So we will subtract the power by 1. So in this case, we are going to have 2x. So 2 minus 1 will give us 1. So we can just write 2x. So we have differentiate x squared. So we have 2x minus. So if you want to differentiate a constant, just like any number, without carrying a variable, so a constant, if you differentiate it, you are going to get 0. So we have 0 divided by. Also, in order to differentiate x, remember that x is raised to power 1. So the power is not visible because anything raised to power 1 is that thing. So in order to differentiate this, the power will come to the front. We will have 1 multiplied by x, and also the power will be raised to power 1 minus 1. So we'll subtract 1 from the power. So 1 multiplied by x will give us x, and 1 minus 1 will give us 0. So anything raised to power 0 is 1. So we have x raised to power 0 to give us 1. So anything raised to power 0, you are going to get 1. So in this case, when we differentiate x, we are going to get 1, and we have minus. So I said earlier that if you differentiate any constant, you are going to get 0. So if we solve this, we are going to have 2x divided by 1. So this is our final answer, which is equal to 2x. So remember that we have the limit x tends to 2. So that means that we can now use the direct substitution method. So in using the direct substitution method, we have two open brackets. What is x? Remember that x tends to 2, which means x is equal to 2. So we have x to be equal to 2. So we now have two open bracket 2, because when we substitute x, we are going to put 2. So we have 2 multiplied by 2, which will give us 4. And that will be our final answer to question of this type. So you can see the difference using the direct substitution method and the L'Hopital's rule. So you can see when we use the direct substitution method, we get 0 divided by 0, which is what? Undefined or indeterminate. But when we use the L'Hopital's rule, you can see we get 4 as our final answer. So this is how you use the L'Hopital's rule. When you have used the direct substitution method and you get 0 as your denominator or undefined, you are going to change to what? To L'Hopital's rule to get your final answer. So L'Hopital's rule, you are going to differentiate everything, and then after differentiating, you are going to substitute. And that is how we solve questions of this type. So let's look at another question still on the L'Hopital's method. And moving to the next question as displayed on the screen, the question says, find the limit of x squared minus 9 divided by x minus 3 at x tends to 3. So in this kind of question, if we are to use the direct substitution method, let's say we use the direct substitution method by substituting x is equal to 3. So we are going to have 3 minus 3 because x will be equal to 3, and we are going to have 3 minus 3, which will give us what? 0. And when we have 0 as our denominator, we are going to get what? Undefined or an indeterminate answer. So in this kind of question, we are not going to use the what? The direct substitution method. So we are going to use the L'Hopital's rule. So can you try and pause this video and try solving it yourself? And once you are done solving, you can resume back to playing the video and see if you are right or wrong. So give it a try and solve the question. So in solving this kind of question, we are going to write what we have in the bracket, which is x squared minus 9 divided by what? X minus 3. So I said when you want to solve using the L'Hopital's rule, you are going to differentiate everything that you have in the equation. And in differentiating, we said the power will come to the front. So when you differentiate x squared, you are going to get 2x, because when the power comes to the front, you have 2 multiplied by x raised to power 2 minus 1. So you get 2x raised to power 1. And 2x raised to power 1 is the same thing as 2x, because anything raised to power 1 is that thing. So we have 2x minus. So when you differentiate 9, which is a constant, you are going to get 0. And we have divided by. So when you differentiate x, just like what we have here, you are going to get x raised to power 0. And anything raised to power 0 is 1. So you are going to have 1 minus another constant, which is 3. When you differentiate a constant, you are going to have 0. So our final verdict will be equal to 2x divided by 1, which is equal to 2x. So now that we have gotten this, we can now use the what? The direct substitution method by substituting x to 3, because x tends to 3 in our question. So in order to use the direct substitution method, we are going to have 2 open brackets. What is our x? X is equal to 3. So and our final answer will be equal to 6. So looking at the question we have, option B is correct to this kind of question. So 6 is correct to this question. And this is how you solve questions under the L'Hopital's rule. So let's look at another example still on the L'Hopital's rule. So moving to the last example on the L'Hopital's rule, we have the question which says find the limit of x cubed minus 3x plus 2 divided by x squared minus 1 at x tends to 1. So in this kind of question, if you want to be sure to use the direct substitution method, you can just look at the denominator by substituting x equals to 1. So when you have x equals to 1, we are going to have 1 squared minus 1, and we'll get 0. So when we get 0 as our denominator, we are going to have an undefined answer or indeterminate answer. And we don't want that in our equation. So that is where to use the L'Hopital's rule. So in order to use the L'Hopital's rule, I said you are going to write everything you have initially, which is x cubed minus 3x plus 2 divided by x squared minus 1. So after writing this, the next thing you are going to do is to differentiate everything that you have in the equation. So in differentiating x cubed, I said the power will come to the front. So we have 3 multiplied by x, and the power will be subtracted by 1. So we have 3 minus 1. So in this case, we are going to have 3x raised to power 2. So when we differentiate x squared, we are going to have what? 3x raised to power 2, and we have minus. So in this kind of question, we are going to differentiate 3x also. So in differentiating 3x, we know that 3x, the power is 1. So we have 1 multiplied by 3x raised to power what? 1 minus 1. Because the power here is 1. Because anything raised to power 1 is that thing. So x raised to power 1 is x. So we are going to have 1 multiplied by 3x raised to power 1 minus 1. So in this case, we are going to have 3x raised to power 0. And we say anything raised to power 0 is 1. So we have 3 multiplied by 1, which will give us 3. So when we differentiate 3x, we are going to have 3. And the last one plus, when we differentiate 2, we are going to have 0, because 2 is a constant. So we have divided by. So also we have x squared. So in differentiating x squared, the power will come to the front, which will give us 2 multiplied by x raised to power what? 2 minus 1. So we have 2x raised to power 2 minus 1 will give us 1. And anything raised to power 1 is that thing. So we are going to have 2x. So in differentiating x squared, we are going to have what? 2x. And the last one, which is a constant. So when you differentiate 1 as a constant, you are going to get 0. So our final verdict, we are going to have 3x squared minus 3 divided by 2x. Because minus 0, you are going to cancel that 0. So now that we have differentiate, the next thing to do is to what? To substitute your limit, which is 1. So in this case, we are going to substitute this limit by putting 1 anywhere we see x. So we are going to have 3 open bracket 1 square, because our x is equal to 1, minus 3 divided by 2 open bracket 1. So 1 square will give us 1. So 3 multiplied by 1 will give us what? So we are going to have 3 minus 3 divided by 2 multiplied by 1 will give us 2. So in solving this question, we are going to have 0 divided by 2. So 0 divided by 2 will give us what? 0. So it will not give us undefined, because so far 0 is not your denominator, you are going to get a value. But if 0 is your denominator, you are not going to get any value. You are going to get an undefined or indeterminate answer. So 0 is correct to this kind of question, and option A is correct to this question. So you can see the option on the screen. Option A is correct to this kind of question. And this will be all on the L'Hopital's rule. Let's move to the last method of limit, which is the limit to infinity. And moving to the last method of limit, we have the limit to infinity. And by definition, the limit to infinity is used when the value of x approaches a larger value, like x tends to negative infinity or x tends to positive infinity. So in this kind of question, you are going to use the limit to infinity when you see x tends to negative infinity or x tends to positive infinity. So you are less concerned about the sign, either negative or positive. You are going to use the same method for both. So the sign does not mean anything. They are just telling you that x tends to a positive infinite number or x tends to a negative infinite number. But you are going to use the same method for any question under the limit to infinity. So let's look at examples under the limit to infinity. So the first example, as written on the board, says that find the limit of 3x squared plus 5 divided by 6x squared minus x at x tends to infinity. So in this kind of question, we're having x tends to what? Positive infinity, because they are not writing any sign in this infinity. So you are going to use the same method, either positive infinity or negative infinity. So if you want to solve any question under the limit to infinity, the first thing to do is that you look for the highest power. So the highest power, looking for the highest power, either x squared or x. So the highest power in this equation that we are given is what? X squared. So we have the highest power to be equal to x squared. So you might see the highest power in another question as x raised to power 4, x raised to power 5, or x raised to power 6, or x raised to power anything. But the only thing, or the first thing that you have to do first is to look for the highest power whenever you want to solve any question under the limit to infinity. So you are going to look for the highest power, and in our case, the highest power is x squared. So now that we have looked for the highest power, one thing that you should note at the back of your mind is that if the highest power is in the denominator, you are going to get 0 as your final answer. Either any question you solve, you are going to get 0 if the highest power is what? The denominator. But if the highest power is in the numerator, you are going to get a value. You are not going to get 0. But if the power is equal, you can see in this case, we have x squared in the numerator and x squared in the denominator. So the power is equal. You are still going to get a value. But if the power in the denominator is greater than the power in the numerator, you are going to get 0. So in this case, you are not expected to get 0 because the power is equal. So let's solve this question and see what we are going to get. So remember, the first thing is to look for what? The highest power, which in our case is what? X squared. So now that we have looked for the highest power, the second step, which is step 2, is to divide everything in the equation by the highest power. So in doing this, we have 3x squared divided by x squared plus 5 divided by x squared divided by 6x squared divided by x squared, and also we have minus x divided by x squared. So this is the second step whenever you want to calculate any question under the limit to infinity. The first step is to look for the highest power, and the second step is to divide everything in the equation by the highest power. So in this case, when you divide this will cancel this, so you have 3 plus 5 over x squared, because they don't have anything in common, so we are going to rewrite it. divided by, so this we also cancel this, so we have 6 minus, so in this case this x will cancel this x, so the power will cancel the x, so we have 1 divided by x. So now that we have divide our equation, so you can see this is what we are going to have. So the last step, which is the step 3, is to limit x to 0. So that means that anywhere you see x, you are going to equate it to 0. So this is the last step, and you get your final answer for limit to infinity. So limiting x to 0, we have 3 plus, so we have 5 divided by, so anywhere you see x, you put what? 0. So we have 0 square, also divided by 6 minus 1 divided by 0. So on a norms, we are supposed to get what? Undefined as our answer, because anything that is divided by 0 will give us undefined. But we are going to neglect it because we are dealing with what? Infinity. So this will cancel, and also this will cancel. So our final verdict, we are going to have 3 divided by 6, which is equal to 1/2, which will give us what? Our final answer to this kind of question. So 1/2 is correct to this kind of question, and this is how we solve questions under the limit to infinity. So let's look at another example to see what we are going to get. And moving to the next question, we have the limit of 5x cubed plus x divided by x raised to power 4 plus 2 at x tends to infinity. So like I said earlier, whenever you want to solve any question under the limit to infinity, the first step, which is the step 1, is to find what? The highest power. So the highest power here is what? Is equal to x raised to power 4. So that is the highest power that we have here. You can see we have x raised to power 3, we have x, and we have x raised to power 4. So the highest power is what? X raised to power 4. So that is the first step whenever you want to solve any question under the limit to infinity. And remember what I said when we are solving our first example. I said that if the denominator has the highest power, definitely you are going to get 0 in your answer, because whenever the denominator is having the highest power, you are going to get 0. But if the power is equal, you are going to get a value. But if the denominator is having the highest power, you are going to get 0. Unlike if the numerator is having the highest power, you are going to get a value. But in this case, the denominator is having the highest power, so we are expected to get 0 to this kind of question. So that is what you have to note at the back of your mind. So this will guide you in solving your question under the limit to infinity. So if the denominator is having the highest power, you are going to get 0. But if the power is equal, or the numerator is having the highest power, you are going to get a value. So in this kind of question, now that we have gotten the highest power to be equal to x raised to power 4, so the second step is to divide everything in the equation by the highest power. So we have our step 2, to divide everything in the equation by the highest power. So we have 5x cubed divided by x raised to power 4, and we have plus x divided by x raised to power 4, and we have divided by x raised to power 4 divided by x raised to power 4, and we also have plus 2 divided by x raised to power 4. So in this case, this x cube can cancel x raised to power 4, and this x can cancel one of these x raised to power 4. So we are going to have 5 divided by x plus, so when the x cancel this, we are going to have 1 divided by what? X raised to power 3. And we are going to have divided by, so this x raised to power 4 can cancel x raised to power 4, and we are going to have 1 plus 2 divided by x raised to power 4, because they don't have anything in common. So now that we have gotten this after our division, the next step, or the last step, which is the step 3, is to limit x to 0. So we have lim x to 0. So that means wherever we see x, we are going to turn it to 0, or substitute it for 0. So we have 5 divided by 0 plus 1 divided by 0 cube all over 1 plus 2 divided by 0 raised to power 4. So in this kind of question, all this can cancel to be equal to 0, because 5 divided by 0, you are going to get undefined as your answer. But everything here will be equal to 0. So we have 0 divided by, so this one too will be equal to 0. So we have 1. So we have 0 divided by 1, which will give us what? 0. So like I said earlier, if the power in the denominator is higher than the power in the numerator, you are going to get 0 as your answer. So you can see we are right. So 0 is correct to this kind of question. And this is how you solve questions under the limit to infinity. So let's look at the last example on the limit to infinity. And moving to the last question as displayed on the screen, the question says, find the limit of 2x cubed plus 3x divided by 5x cubed minus x squared at x tends to infinity. So can you try to pause this video and solve this question? And once you are done solving, you can resume back to playing the video, and once I solve it, you see if you are right or wrong. So pause this video now and give it a go. So in solving this kind of question, I said we are going to, the first step is to look for what? The highest power. So which is the step 1, to look for the highest power. And the highest power in our case is equal to what? So if you look at all these equations, what is the highest power? The highest power is what? X raised to power 3. That is our highest power. So just like what I said earlier, if the power is equal, we are going to get a value. So we are expected to get a number value in this case and not 0, because what? The denominator power is not higher than the numerator power. So we are expected to get a value. So now that we have gotten the highest power, the next step, which is the step 2, is to divide everything in the equation by the highest power. So we have to divide everything that we have in this equation by the highest power. So you can see we are using the same step for everything. So whenever you have any question under the limit to infinity, you are going to use the same step and you get your final answer. So in dividing the equation with the highest power, we have 2x cubed divided by what? X cubed plus 3x divided by x cubed divided by what? 5x cubed divided by x cubed plus x squared divided by x cubed. So now that we have divided everything by the highest power, we can just cut it. So we have 2 plus, so this will cancel this. So we have 3 over x squared, because this is x cubed. So when we remove one x from x cubed, we are going to have what? X squared. And we now have divided by, so this x cubed can also cancel this. So we have 5 plus, so this can also cancel this. So we have 1 over x. So now that we have divided to get our final answer, the next step or the last step to do, which is the step 3, is to what? Is to limit x to 0. So that means wherever we see x, we are going to substitute it for 0. So in doing this, we have 2 plus 3 divided by what? 0 square all over 5 plus, so 1 divided by 0. So all this will be equal to 0. So we have our final answer to be equal to 2 divided by 5. So 2 divided by 5 is correct to this kind of question. So from what we have on the screen, option A is correct to this kind of question. So 2 over 5 is correct to this kind of question. And this is how you solve any question under the limit to infinity. So this will be all on the limit of a function. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And if you found this video helpful, don't forget to like this video, hit that subscribe button and turn on the notification bell so you won't miss any lesson or any updates from Tech and EduSpark. And share this video to many friends. And until next time, keep learning, keep coding, and I'll see you in the next one.